Our next presenter is Dr. David Anderson. Dr. David Anderson is a professor of anthropology at the University of Tennessee. He will be giving a presentation on addressing climate change and the loss of cultural heritage through a perspective from the southeastern United States.
Can you see my screen okay?
Yes, it looks perfect.
Okay, excellent. I'd like to start by thanking McKenna for inviting me to this, and to all of you for listening. It's a wonderful presentation session, and I'm happy to be a part of it. Well, we're all exploring two big questions. How does climate change threaten cultural heritage? And then how do we respond? And in this paper, I'm going to look at those questions, and I'm also going to suggest what it might cost. The emphasis in this talk is on terrestrial resources. However, many of the recorded sites and structures we work with are in tidal and nearshore environments, as we've seen in the preceding talks. Now, slow onset climate and related changes linked to cultural heritage. There are a number of things that affect it: sea level rise, permafrost melting, changes in precipitation and temperature in biota, ocean acidification, the subject of the next talk, changes in health and mortality, and then migration inland into healthier areas. Sudden changes in these variables are what are called rapid onset events and are known as extreme weather events. Now, sea level change is, of course, something that we're all interested in this session. And there are a number of different scenarios for sea level rise through the remainder of this century, with projections from under a meter to perhaps 6 meters or more. One of the things my colleagues and I have done is look at the occurrence of sites that are threatened by sea level rise. And in the southeastern United States alone, in a 9-state sample, there are literally thousands of sites that are at risk. Basically, a 1 meter rise will affect 20,000 known recorded sites, and a 5 meter rise close to 30,000 known sites. Of these, 1,300, given a 1 meter rise, are on the National Register of Historic Places as eligible properties. Now, the study that was done in the Southeast has been done in a number of parts of the world. These are World Heritage sites in the Mediterranean Basin, looking at the effects of sea level rise on them, and there are studies from other parts of the world as well. Now, sea level rise will affect a wide range of sites. The Lighthouse Explorer gives a list of 56 threatened lighthouses that are within a few meters of moderate sea level. And I actually believe, based on work at Body Island, that there are probably many more lighthouses at risk. This gets into relocation as a form of climate mitigation. Moving the Cape Hatteras Lighthouse is perhaps the most famous example. 4,800 tons was moved 3,000 feet inland. The Kennedy Space Center is a major historic and, of course, active site at risk. And interestingly enough, Saturn V rockets weigh about the same as the Cape Hatteras Lighthouse, so we're used to moving large objects. It isn't just the large and the dramatic. The Union of Concerned Scientists did a study showing that 2.4 million residential properties and 100,000 plus commercial properties worth over $1 trillion are at risk in our country from chronic flooding due to sea level rise. The permafrost regions occupy 23 million square kilometers in the Northern Hemisphere. Those are at risk as well. The melting of the permafrost includes between 7 and 8 million square kilometers in Alaska and in Northern Canada in our hemisphere alone. The nature of the preservation in these environments is remarkable. It requires substantial recovery, conservation, and curation efforts. Other affected changes include in precipitation and temperature, where dramatic changes are expected this century. And in biota, basically the projected changes in ranges are pretty dramatic from 1990 to 2100. Ocean acidification, again, which we'll be seeing as CO2 in the ocean increases, the green in the chart, pH decreases and acidification increases. This has effects on submerged cultural resources, as we've seen and will continue to see in these sessions. There'll be dramatic changes in health and mortality, particularly that will result in migration. There'll be changes in the ideal human temperature niche that are pretty dramatic, meaning that people will have to move to avoid unusually hot weather. Now, extreme weather events are also something that will be occurring increasingly, and this is the IPCC definition. It's an event that is rare at a particular place and time of year, and that basically means it's rarer than the 10th or 90th percentile of a probability distribution. So you're all familiar with this chart. Extreme weather events are increasing and will continue to do so. Perhaps the most dramatic in recent years in the United States is Hurricane Sandy as an extreme weather event. And slow onset climate change coupled with these extreme weather events will lead to millions of people having to move in the years to come. In fact, a substantial portion of the Earth's population will need to migrate inland or to cooler areas, something that is being called managed retreat. These slides, this is being recorded, and I'll be happy to email these slides to anyone as well so you can get the references and the details. Now, protection in place is not an option in most cases. That's why we call it managed retreat. Building seawalls, one potential solution, has the potential to damage vast area, and estimates are in the trillions of dollars to preserve large areas. In the southeastern United States alone, the study my colleagues and I did showed that approximately 3 million people are going to need to relocate given a 1-meter rise in sea level. So how do we address the loss of cultural resources moving forward? First, we need to continually refine our modeling efforts. The bathtub model that my colleagues and I did has been superseded by better models looking at rainfall and storm surge and others. We need to keep doing that. We need to conduct more excavations, more survey. We need to involve many more parties and people. We're all stakeholders in this. And a classic example is the South Carolina DNR's Bouquet Island Shell Ring Archaeology project. We need to recognize that impacts aren't restricted just to coastal areas. Excessive rainfall and flooding can undercut banks along our major river systems. An example that I worked with was at the Shiloh National Battlefield. There was a major Indian mound group on the site that was being undercut by the Tennessee River and literally eroding into the river. A mitigation plan involves some 4,000 person days of field work at that site. You can see the scale of the excavations that took place. One of the things we're going to do is we're going to learn a lot of new things about the human past, as well as how to deal with large projects like this. One of the things we learned from this project was that the appearance of mounds built by first peoples was quite different than we have assumed. So basically, they weren't green, grass-covered, short grass-covered monuments. They were quite probably colored in many cases. So we need to develop diverse and iterative approaches to our response. We need to ensure collaboration and participation by all the impacted parties. We need to consider a wide array of cultural and research concerns, decolonizing our practice and building our capacity. We need to consider multiple perspectives and multiple voices in planning, conducting the research, curation, and in reporting. We need to recognize our biases and what we consider significant sites. This is Louis Vork's wonderful paper showing that many World Heritage sites currently listed reflect hierarchical and not more traditional horizontal or egalitarian forms of socio-political organization. We need to recognize that mitigation must encompass a wide range of cultural resources. And a classic example of these things being done are on reservoir projects. This is one I worked with extensively about 40 years ago. So I'll be talking about it. Detailed plans are needed for climate change mitigation. The Russell Reservoir, before the fieldwork started, had a 3-volume, roughly 1,000-page mitigation plan. We need to be thinking about these things. It surveyed 210 square kilometers, finding about 1 site per 71 acres, and then a large numbers of these sites were examined. The cost of this program was about $5 million in 1980. These are slides of some of the excavations that took place, very traditional excavations. Some large scale, entire villages were examined late pre-contact. But there was also other site types considered, industrial archaeology, mill sites, for example. There was the architectural documentation of structures, and we remember the numbers. We're going to lose large numbers of structures in coastal areas. There was also oral history of groups that are traditionally not examined in such projects. There was also the relocation of structures. It won't just be the Cape Hatteras Light. There were bridges, there were houses, things like that that were moved out of the flood pool. Unanticipated consequences. It became clear during the excavations and the related work that the Savannah River Valley was abandoned around 1450 AD. And subsequent research showed that climate change likely played a role. There was a decrease in rainfall associated with the emergence of fortifications and then the abandonment of sites in the area. So a global level of effort is needed in information management and planning, and I like to see the NOAA system in place, and we actually need this between all agencies and indeed the state site file managers as well in the US, and then of course going well beyond that. Two of the projects I've been involved with are the Paleo-Indian Database of the Americas and the Digital Index of North American Archaeology, where we're trying to integrate and index large numbers of sites. We need to design appropriate field procedures as well as analysis and reporting efforts. One of the very effective techniques that's come along is using LiDAR and other imaging directed to locating subtle elevational differences in coastal environments. You can see shell rings here, but they can also be used to find race dikes, roads, and other structures. Geoarchaeologically informed analyses directed to site discovery are also important. We can use LiDAR, again, in this case at the Shiloh battlefield, to fly and assess erosion conditions. We had LiDAR imagery of the mound that was falling into the river, and we're able to reconstruct, this was just a few years ago, reconstruct the extent of loss that had taken place since the mitigation. And we need to use remote sensing to prioritize excavations. This is houses around the plaza at the Etowah Mound Group in Georgia. Curation is a critical part of this. We need to make sure what is saved is maintained for the long term, and it has to be in secure facilities and areas well inland from the coast. The curation is for public education and research. It shouldn't just be stored, it should be accessed and used. So the results at every stage of the process should be publicly reported, widely shared, and guide subsequent stages. In the Russell Reservoir, we had technical syntheses that were produced of both the pre-contact and historic archaeology. There were also popular overviews produced in literally thousands of copies and distributed to schools throughout Georgia for both the archaeology and the oral history. So a big question is, how do we estimate the numbers of archaeological sites on lands threatened with sea level rise? Well, nearly 50,000 square kilometers will be lost in the southeast given a 1 meter rise in sea level. This is a 500,000 site sample from the DINA database. And of course, some areas are much more intensely surveyed than others, typically federal lands where there are the resources to pay for those costs. This is the Francis Marion National Forest, for example. One of the things we can do is compare survey intensity and site incidents in threatened areas. On intensively surveyed federal lands, in a sample of the installations in the southeast, the average is about 1 site per 110 acres. These figures compared to the total number of recorded sites in the region. You can see that the numbers of acres per site, the fifth column over, is roughly between 600 and 700. So basically, the numbers of sites that are out there is probably 6 or 7 times as high as what we have already recorded, because the vast majority of the area has not been intensively surveyed and hence has a very low site incidence. The next question, how do we estimate what it would cost to survey and mitigate these, the loss of cultural heritage? Well, archaeological inventory survey costs vary widely, But a very rough ballpark based on studies that have been conducted is between $100 and $1,000 an acre for survey and evaluation. Now, doing the numbers, basically in terms of the acreage in the southeast, a rise of sea level of 1 meter, the cost would range at 100, about 1.2, and 1,000, 12.2 billion. And then, of course, as sea level rises beyond that, the costs increase. Now, another way to estimate mitigation costs is just to look at large projects that have happened in the past. The Russell Reservoir examined 215 square kilometers and cost $5 million in 1980 dollars, or roughly 16 million in today's dollars. Now, a 1 meter rise in sea level will submerge an area equivalent to nearly 250 of these reservoir projects across just the southeastern US alone. The Russell Reservoir project, again, $16 million today, would probably look at a lot more sites than we did then, so you can up that a bit, but that gives you a ballpark. So the southeastern coastal mitigation, based on a traditional archaeological model, is about $4 billion if we look at the numbers of potential projects, and that's in today's money. Now, given that sea level rise threatens coastal areas, and that's where people have been living for the last 6,000 years, as sea level has been relatively stable during that time, the actual cost of mitigation is likely to be several times higher. So I just said, let's multiply that by 3, and the figure comes out to about $12 billion. Now, this is amortized over the course of the next 50, 60 years. And in comparison, this is 0.06% of the proposed stimulus infrastructure bill. So amortized over a long period of time, it isn't really that much money if we, again, use a traditional archaeological model. And if we double the numbers, it's still not a lot compared to what we are spending currently per year. So to conclude, there's no doubt that climate change poses tremendous challenges for archaeologists and indeed for our civilization. I think it's our greatest challenge this century is to get through it with a stable civilization and a well-preserved heritage. We've faced these challenges before. There are over 8,100 major dam sites that have been built in the United States in the last 150 years. And many of them had cultural resource investigations, not as complete as in the Russell Reservoir, which was one of the last ones built, but we have done this before. So I believe we can meet this challenge, we will meet it, but we need to be planning accordingly and thinking in terms of the scale and integrating information over large areas. So thank you very much, and I'll be happy to take any questions now.
Thank you so much for your talk, Dr. Anderson. Seeing climate change and its impacts on maritime heritage from the perspective of Southeastern United States was very meaningful and interesting. Do you all have any questions? If so, please put them in the chat box. We have many compliments saying thank you very much for a great presentation.
I appreciate that, and thank you again for inviting me. And it's a great series of talks, so I appreciate that, the opportunity. And again, if people would like the slides, and I want you to know I've cut this talk in about half from what I gave at the Cultural Heritage at Risk session in January, so I can give full versions of the talks, email them to anybody who would like, and it will be recorded and available. So thank you again.
There is a question, and it's, have there been any studies as to where populations may move, have moved, and how this impacts sites in the areas to which they move?
Yes, great question. There are studies of migration, anticipated migration patterns that have been undertaken. Now, how this affects cultural resources has not been undertaken, but you can basically assume that if large numbers of people are moving inland, the areas they leave behind will need to be evaluated and salvaged, rescued, triaged in some way. And then the areas where they move to we'll see increased development. So that's something that people will be thinking of. Again, we haven't been really planning on beyond an agency or state basis on this, and we really need to combine a lot of informatics, a lot of information, and a lot of thinking. And as someone in the last talk said, we need groups like this to be discussing these issues.
Very nice, very interesting as well. Another question is, with regard to the cost of mitigation versus construction, do you have a central fund for archaeological mitigation in advance of construction in the USA?
Well, under the National Historic Preservation Act, as modified in 1974, up to 1% of any federally funded, licensed, or backed project can go to the evaluation and mitigation of cultural resources that might be impacted by that project. So that is one source of funding. And indeed, the National Historic Preservation Act and the Historic Preservation Fund, which results in the funding of many state offices and mandates action by, again, federal agencies. We heard the NOAA people previously talk about how they follow it. There are funding mechanisms there. However, in the 1960s and 70s, what archaeologists did, and heritage resource managers, I guess you could say, was they made a concerted effort to ensure that cultural resources were included in what was called then the crisis in American archaeology, the large numbers of sites that were being lost. I think we need a similar effort. And indeed, with the new infrastructure bill, for example, we have to ensure that cultural resources are considered, that they aren't short-circuited or ignored. And fortunately, with the legislative mandate, that's very unlikely to happen.
Great. Another question is, are there any examples of prioritization for selecting cultural sites for evaluation for climate change already being attempted, perhaps FEMA?
Yeah, the Federal Emergency Management Administration and other agencies responsible for things like oil spill mitigation and so on. Oftentimes large areas are impacted and a form of assessment and triage, and then mitigation has to occur. Again, this has been done in some areas and at some scales, but not at the scale we need, given that the climate change is affecting resources across the planet, from the Arctic to coastal areas. So it's a great question. We need to be thinking about that, and that's one reason why my colleagues and I built the Digital Index of North American Archaeology. It's an informatics platform. The software is open access. Anybody can take it and build on it. It's a model for integrating archaeological data and pointing to other data sets out there. And you're welcome to take it and use it or link to it. So we need to be thinking on those levels.
Very interesting. Is there any other questions? We do have a few more minutes to address any questions that you may have.
Well, thank you again very much. It's a great session, and I again appreciate participating in it.
Well, thank you for coming and presenting. It was very meaningful.